Thank you all so much for coming tonight, and welcome. I hate to say this, it's unfortunate. Welcome to our second annual California Drought Panel. I was just talking with a couple of our panelists today, and we're hoping that it's the last annual California Drought Panel, at least for the time being. But then we started talking about how much rain we would need to get between now and next March in order to be able to say that, and that's an interesting question to try to answer. And we're still in very bad shape, which raises a series of questions that I hope our panel tonight, I'm sure they will address to at least some degree.
So the current drought is actually already the third wave of drought in California in the 21st century so far. So we've already essentially had 3 droughts in the last 15 years. And as you can see on the plot I have up on the screen, the current wave of drought is by far the most intense and already the most prolonged going into 2015. You can also see that the drought began pretty abruptly during calendar year 2012 and then persisted at roughly the same intensity through 2013 and then really sort of skyrocketed in early 2013 into 2014 and if you were in California at that time, you probably remember that's when precipitation essentially fell off a cliff. And since then, the intensity has been more or less constantly exceeding extreme to exceptional severity up to this date right now. And this is just a map of sort of the same quantity I had plotted as the time series before. And really what I want to point out here is that California is really the center of a much broader drought across the American Southwest. And that broad drought across the Southwest has persisted for much longer than the current drought event in California. But it's also true that the current drought in California is of considerably greater severity than the broader drought in the American Southwest.
So how did agriculture get through the last year? They resorted to groundwater. And in fact, if you take the total amount of surface water that agriculture was cut back, they made up for about 75% of that by pumping groundwater. The problem, however, is, as Daniel pointed out earlier, that leads to a huge overdrafting of our groundwater aquifers. We need a system where we actually have better statistics about water. We do need to continue to come up with new storage facilities. And thankfully, last year we passed Proposition 1, which is providing about $2.7 billion to help us in constructing storage. Problem is that a lot of us are thinking about using that money for surface storage. And the truth of the matter is that new surface storage would be very expensive. And in addition to being expensive, even if we built the major surface reservoirs that we're talking about in the Central Valley today, it would only increase the total amount of storage in California by about 7%, and it would only increase the amount of water available in a typical year by 1%. And the other problem with storage is it doesn't work unless you have water to store. And if you're in a 4th year of a drought, then frequently you don't have the water that you actually need to store. Another thing we have to do is we have to have more effective water markets in California. That permits people who don't have the water to actually acquire the water from people who might be able to get by with water, with less water in a particular year.
So looking at the future, where do we go from here? We've taken our water use down quite a bit, our potable water use, but the campus is going to continue to grow, like California. But we do have another big opportunity to reduce our domestic water use. And that's with a new energy plant that's coming on in about a month. It's finishing construction right now. So this plant is ready to start up. What it will do is, because our energy plant before used about 1/4 of all of our domestic water, this new plant with its inherent energy recovery systems is going to be much more efficient. And by the way, it's not going to use cooling towers to produce chilled water anymore. It's going to reduce the energy plant's domestic water use by about 70%. So that'll save overall 15% of our domestic water demand, starting in about 3 weeks when this thing fires up.